Hello, everybody. This is Becky Bewitched back at you with another video. We are tonight going to talk about um, we're going to talk tonight about some math. Um, Thank you so much for those of you in the comments. It's so great to see you all, random people I have never met, and we have a little celebrity here, A&D cosplay. How fun! All right, so let's get started with some math. Thank you, Mr. Risco. Yes, I'm here. Hi, how are you? Hello. All right, let's get started with some math. So tonight we're going to talk about simplifying trigonometric identities. Trig identities are kind of, if you think, I like to think of it as like a superhero. There are some superheroes. Oh, thank you, Mr. Risco. Stop. Um, I'm going. I like to think of it as essentially, superheroes and their different identities. They have their street identities, and then they have their identities where they are superhero. Tonight, we're going to be talking about this in math, as it's related to trigonometry specifically, and we are going to look at some of the superhero identities for these trig functions. Oh, thank you, Miss Viral. Real. Thank you. Yes. Well, just want to make sure we know I'm in the air. Well, Mr. Risco, you are so nice. Okay. Let's first look at what the trig identities are. So as you can see, we are going to go by the rule that sine and cosine always stay the same. Okay, get a good look at these. So cosecant is the inverse of sine, as you can see there. Secant is the inverse of cosine. All right, and then we have tangent and cotangent, which are like combos, but they are also inverses of each other. This little circle right here, that's called theta. Theta represents an unknown angle in mathematics, so it's just a symbol. Don't let it freak you out. Just focus on the function itself. Okay? No, don't get stressed. It's okay. Nope, no test. All right, so check this out. We're going to simplify this thing. All right, if you notice here, just follow on my questions. If you notice here, we have this example, sine of theta, cosecant of theta. Okay. Question, which identities can always stay the same or should always stay the same? If anyone knows the answer, please feel free. Which identities should always stay the same? Please feel free to type it in the chat. Very good, Andy. Yes, sine and cosine, we're always going to keep those two the same. All right, so we are just going to, when we see them in a problem, as right here, which of these two functions, sine or cosine, do you see in this problem? Which of these functions, sine or cosine, do you see? Excellent job, Sarah. Very good. Very good. Okay, yes. Sine, as you can see, is in the problem. So, because sine and cosine always stay the same, I'm going to bring my sine down. Any questions on that so far? Hello, Miss Black and Miss Chase. I'm just going to call you by your first names. Okay, so because sine and cosine always stay the same, I just brought this down. Now this one, though, we're going to switch this identity out for a different one using our handy-dandy trig identities chart. So in this problem, we have CSC. Can anyone, using the trig identities chart, please tell me the other identity for CSC? What is the other identity for CSC? Thank you, Mr. Risco. Mr. Risco, do you have an answer to the question? Excellent job, Sarah. Very good. Okay, 1 over sine. Very good. So I'm going to take that identity and I'm going to write it here. Okay. So I switch that out. All right. Then we are going to actually look at what we can simplify. So I'm just going to ignore that for now. So looking at this, does anyone see anything that can cancel out? Anything on one of them? There might be something in the top of a fraction. In another one, it might just be by itself or the bot. Do you see anything that can cancel out in this problem? Very good, excellent job, Carly. Yes, the signs can cancel out. So I'm going to cancel those out. Close, not 0. Just whatever you're left with, which in this case is just that 1 in the top. The thetas as well will cancel out. Are there any questions on this problem? We're going to look at another one. Oh. Thank you, Stephen. Thank you. Let's look at another problem. Okay. Example 2. Does anyone see anything that can stay the same in this problem? And remember, the two functions that will always stay the same are sine, S-I-N, and cosine, C-O-S. Does anyone see anything in this problem that can stay the same? Very good. So I'm going to write equal signs this time. I'm going to bring cosine down. However, I am going to switch out this for a different identity. So here we have secant, S-E-C. Can anyone tell me the other identity for secant? So the other identity for SEC. Thank you, A and D. Okay, yes. So 1 over cosine, as you can see, I found secant in my chart. 1 over cosine is the other identity for that. So I'm going to switch that out for 1 over cosine of theta. And then you're going to ask yourself, can anything cancel out from this part? Can anything cancel out? Thank you, Mr. Risco. Excellent job, Sarah. Okay, I'm going to cancel those out. Can anyone tell me what I'm left with? Thank you, Stephen. 1 is correct. Now, you might think that, all the problems are going to come out to equal 1. Well, that's not the case. We're going to look at another example. I can pick up this paper. Okay. Example 3, tangent and cosine. So the first thing to ask is what can stay? And remember, again, the two that can stay are sine, S-I-N, and cosine, C-O-S. What can stay? If anything, sometimes some things can't stay. What can stay the same? Very good, Carly. Yes, cosine can stay the same. So I'm going to bring that down. What needs to be switched out from this? So if we know this is staying the same, what needs to be switched out? Thank you, Stephen. Oh, thank you so much. Yes, tangent needs to be switched out. Thank you for including that in your answer. Okay, let's find the other identity for it. Can anyone tell me the other identity of tangent? TAN. What is the other identity of tangent? Very good. It is sine over cosine. So I'm going to replace tangent with sine over cosine here. Oh, no, it's okay. Don't worry about it. Can anyone tell me what I can cancel out? Very good. Cosine can cancel. What am I left with? What would be my answer? Thank you, Jenna. Very, very good. Sine is correct. So sine is our answer for this one. Junie, can you stop? Junie, thank you. Any questions? Matt? Well, are we up for one more example to, and then we can close out this this lesson? No? Yeah, Tuni has a lot of things. Okay, let's look at one more example. Okay, example 4, we have cotangent, tangent. Cotangent, tangent. Remember, the two that always stay the same are sine and cosine. Is there anything that we can keep the same in this problem? Can anything stay the same? Nope. Sine and cosine are the only two. Yep, no, exactly. Very good. So that means we're going to switch both of these out. Okay, a little bit more work this time. What is the other identity for cotangent? C-O-T. What is the other identity for cotangent? Very good. So I'm going to rewrite that. So I replaced cotangent with cosine over sine. What is the other identity for tangent? T-A-N. The other identity for tangent. Very good. Excellent job, Carly and Sarah. Stephen, I haven't heard. Oh, great. Tuni, I'm live here. Very good, everybody. Okay. Let me ask you this. What can cancel here? What can cancel from this problem? Tuni, can you stop? Thank you. Very good, Jenna. Excellent job. Everything is correct. I can cancel out these. They're ones on the top, ones on the bottom. And same for these. So I'm going to cancel out my sines. And I'm going to cancel out my cosines. What do you think our final answer would be? What would our final answer be if everything in two fractions cancels out? 0 is a very good guess. It is not the correct answer, though. Nope, not 0. Very good, Stephen. Very good, Sarah. The answer is 1. And the reason is is because when you have two fractions that are opposite of one another, such as 5/4 or 4/5, if you were multiplying this in a regular problem, you would multiply the top two numbers and the top bottom numbers. So I would do 5 times 4, which is 20. And then on the bottom, I would do 4 times 5 if I were solving this as a normal problem. Then you're left with a division problem. 20 divided by 20 is 1. If you notice, we're doing the exact same thing just with trig functions. Even though there's no sign in the middle, no little dot, when we have two terms with parentheses around them, they are being multiplied by one another. Hence why we are eventually left with 1. Okay, that is going to conclude our lesson for tonight. I just want you to all know, though, I really appreciate you coming onto this stream, the long-awaited stream. And I also want you to know that even though we got some examples in, there is so much more to this lesson and so many more complex problems. Even they can be in fractions. I did have a couple more examples, but because of time, so even like we can do addition problems. There are actually so much more to this particular lesson that we were not even able to bridge the gap of. But just wanted to thank you all again so much for tuning in. And that is all for now. Becky Bewitched is gonna leave now. Oh, thank you, Mr. Risco. Thank you, Stephen. And Stephen, don't worry. Thank you so much, everybody. Okay, I'm gonna press the end button. Junie says bye too.